This unit, we're going to start with what we call parallelograms. Now, very interesting on the word parallelogram. Notice how it starts with parallel. And in parallel, we learned before that it's two lines that never intersect. And that's actually what a parallelogram is. It's a couple of pairs. So a couple of pairs. So basically two pairs of parallel segments. So what this means is there's a segment on the top and there's a segment at the bottom that they are going to be parallel, but there's also going to be a segment on the left and a segment on the right that are also going to be parallel. So this is actually what makes a parallelogram. Interesting part of parallelograms is not only the opposite sides are equal, but they are actually congruent. Congruent, we have talked about this word before, same shape, same size. So opposite sides are parallel, but also congruent. So that's actually going to help us for questions 1 and 2. It says solve for x. Each figure is a parallelogram. So I'm looking at the segment RS and I'm looking at the segment QT. I know they're parallel because it is a parallelogram, but they're also the same size. So what I'm going to do to solve for x, I'm just going to let those two sides equal each other. So I'm going to go x plus 11 is equal to 19. Again, opposite sides are parallel, but they're also congruent. So they equal each other. Now, I know that for me to solve this, I'm going to separate it through the equal sign. I want the x by itself, so this plus 11. Let me move it to the other side as a minus 11. Don't forget to switch the sign. So I'm going to get that x is equal to 8. All right, 19 minus 11 gave me 8. That's it. X is equal to 8. Some cases, some of our x's are going to be negative, and that is fine. In this case, it's positive, but some cases in your homework, you might run into being negative. Take a look at question number 2. I see the side FG is 18. I see the side EH, 7x minus 3. But because this is a parallelogram, not only those two sides are parallel, but they're also congruent, they equal each other. So I'm going to say that 18 is equal to 7x minus 3. I'm going to separate my sides to the equal sign. I want the x's by themselves. I only see x on the right side, right? The 7x. So I want the 7x by itself. So this minus 3. Let me move it to the other side as a plus 3. I know 18 plus 3 is 21. So I have that 21 is equal to 7x. To get the x by itself, let me divide both sides by 7 because it's the coefficient of x. All right, coefficient is the fancy word for the numbered in front of. So the number in front of x or the coefficient of x is 7. So I'm going to divide both sides by 7. I know 21 divided by 7 is 3. 7 divided by 7 is 1. So it's not that it just goes away. It becomes a 1. It becomes 1x. So I just write the x by itself. So x is equal to 3. Right? On your homework, just type in the number. Just solve when I say solve, I'm basically asking for the value. Again, some of your cases, they're going to be negative for the value of x, and that is fine. Let's take a look at questions 3 and 4. Architect Ida is designing a custom window for a modern building. The window frame below is not drawn to scale, needs to have a parallelogram shape to complement the building's unique aesthetic. Okay, so I have a window that is going to be a parallelogram. Laying out the frame on the grid, Ida wants 3 of the corners to be point A. The coordinates of A are going to be 0, 0. So here I'm going to say 0, 0. My point B, the coordinates of my point B are going to be 34, 15. Okay. My coordinates of C are going to be 13, 29. What are the coordinates of the fourth corner point D? So we're solving for what are the coordinates of point D? Okay, so my question, when I'm doing my homework, I'm going to see parentheses, I'm going to see a comma in between, and then I have to put in an X value and a Y value. Okay, how am I going to work this out? I mentioned parallelogram, they're the same size. If I knew the length of the sides, I could let them equal each other. That's basically what we did in questions one and two. Another thing that I also said was they are parallel. So what do parallel have? They have the same slope. So I know for slopes, we talked about slopes before. You guys have talked about this in the previous year. Let me take a look at the points A and B. From the point 0, 0, I'm gonna have to go up a little, and then I have to go to the right. Okay. I know that for my slope is direction. So how do I move? So I'm looking for the y values because I had to go up first. From 0, I have to go to 15. Like say I'm comparing my y values. Remember, this is not drawn to scale, but I'm just looking, okay, from 0, I have to go to 15. So doesn't that mean that I have to go up 15? Like a 0 plus 15 gives me 15. Okay. What about the y values? What I do to, I mean, to the x values, we're looking at the x values now. What do I do to 0 to convert it into 34? I'm only adding or subtracting because that's basically what slope is. So what do I do to 0 to make it 34? And I'm only adding or subtracting. Well, plus 34, right? That's basically what I'm going to do. Plus 34. So that's right here. Okay. Basically, what I just said is we had the point 0, 0. I added 34 on the x. I added 15 on the y, and that gives me the point 34, 15. So notice how adding 34 on x, adding 15 on y gives me point B. So that's exactly what I'm going to do to my point C to get the coordinates of D. I'm going to add 34 on X. I'm going to add 15 on Y. And my results are going to be my coordinates of point D. And the reason why is because I'm getting the same slope. Okay, so 13 plus 34, isn't that 47? 29 plus 15. Use a calculator if necessary. 29 plus 15, I get 44. So that's it. Those are those are my coordinates. My coordinates are going to be 47, 44. Okay, right now I'm going to be like, wait a minute. I'm not too sure on this. Let's take a look at similar example. Looking at question number 4. There's architect Alana designing a custom window for a modern building. The window frame below, not drawn to scale, needs to have a parallelogram shape to complement the building's unique aesthetic. Laying out the frame on a grid, Ida wants the three corners of the points to be 0, 0 for A, 32, 12 for B, 12, 27 for C, and then we need to find out what are the coordinates of our point D. Okay, so I'm looking at my points A and B. Whatever I do to my segment AB, it is the same thing I'm going to do on the segment CD. Okay, they are parallel. So I'm just saying, okay, I'm trying to find values. What I do to my coordinates of A such that I'm gonna get the coordinates of B. Okay, I know my coordinates of A are 0, 0. What do I do to those values to make them the coordinates of point B? So adding and subtracting. So looking at the first value, looking at the X value, thinking, what do I do to 0 to make it 32? Well, I add 32, right? Because 0 plus 32 is 32. Good. What do I do to the Y value? Well, I'm going to add 12 because 0 plus 12 is 12. So I'm adding 32 on X and I'm adding 12 on Y. So looking up here at my point C, I said I'm going to add 32 on X and I'm going to add 12, and on Y. Okay, I know 12 plus 32, looking at the X values, 12 plus 32 is 44. So I know my X value for my point D. Then on the other side here, 27 plus 12. I know 27 plus 12 is 39. So that gives me my Y value of my point D. So my coordinates of point D are going to be 44 and 39. Nice.